Good afternoon, everyone. Thank you for joining. We will start our webinar shortly. Just give a minute or so for more participants to join in.
You go back to where it says level 3 people. Oh, okay. So you can register here.
So before we start, just a couple of housekeeping things. Please, everyone, if you are not speaking, please keep your team setting as mute. And this session will be recorded for reference. And once the presentation finished, we will have a Q&A session. So you're very welcome to drop your queries or questions in the chat box for Q&A, or you can raise your hand, turn your sound on to raise questions verbally. So we will start. Thank you very much for joining our webinar, The Recent Drive to Mitigation Air Pollution. My name is Xiang Sheng. I'm a Senior Director at Temple. So today, the presentation will be presented by my colleagues, Daniel and Zen as well. So perhaps I will give you a brief introduction who we are. Temple is a leading independent environmental and sustainability consultancy. Our sectors across infrastructure, property, urban development, transportation, agriculture, land use, and so on. So it's importantly to note Temple is a purpose-driven organization. So our purpose is to make meaningful environmental and social differences together. So in fact, our purpose is fundamental to our activities, which locked in our day-to-day operations. How to make meaningful environmental and social difference together, that's probably the key question driving us forward. This recognizes our ability to work collaboratively in supporting other organizations achieve their sustainability goals as well. You might have noticed there is a B Corp logo on our slides early on. So what is actually a B Corp? Temple is a B Corp certified organization. This recognized as impactful business means we have very high standards of social and environmental performance. We are committed to transparency, and you are very welcome to look up our performance on our website or the B Corp directory. I would encourage you probably check out our sustainability strategy, because this is underpinning everything we do. And very importantly, our sustainability strategy based on the premise of zero harm and net gain. We have 6 material impactful areas, which you can see from this wheel. But more importantly, not only we're operational on that front as a business, but far more impactfully, it's through our services to help other organizations and projects and schemes to really have a meaningful environmental and social impact. So yeah, Without going into too much details, you are very welcome to check out the Sustainability Impact Report, which is available online. In addition, Temple is also an IEMA, part of the IEMA EIA quality mark organization. So we do share our knowledge, best practice, and good quality work on EIA with wider community. So this webinar is also part of that. So briefly, our services covers from planning to environmental impact assessment. We have a very strong ecology team, covers everything from ecology survey to assessment as well as biodiversity net gain. We have our social health, social value team, our ESG team, as well as environmental management and consent. We do offer noise services as well as climate carbon sustainability services. Today, this presentation is carried out by our air quality team. Our subject today is to looking at drivers for air quality mitigation. So our air quality services probably covers every aspects of air quality, from assessment, dispersion modeling, to monitoring, as well as construction dust management, odor, and so on. So without further ado, I would like to introduce my colleague, Daniel. He will run through the legislative requirements, as well as how to mitigate air quality impact. Then my colleague Zan will present a case study. Over to you, Daniel.
Thanks, Sean. So just before we start, I've just got a quick question. If everyone listening could please type your responses into the chat box, and we'll just get a bit of an idea of who's joining us today. So that question is, how much knowledge and experience do you have on air quality and how it's dealt with in the development process? So some suggested responses could be not any so far, or you might have a little, or maybe a lot. And a mixture of responses so far by the look of it. Some people saying quite a lot, others saying little. Yeah, broad range across quite all three of those, which is interesting to see. So hopefully this will be helping everyone, and I'll get going. So just to start off, why do we assess air quality and mitigate impacts? So I suppose a lot of people will understand it's to ensure that legislative and policy requirements are met in planning and environmental permitting processes. Obviously, there's a need to prevent delays to determination due to non-compliance and the impacts that can have on time, resources on the programme. You may also wish to help to implement best practice, because air pollution can have an impact on human health and biodiversity. So there's always a drive to prevent impacts in those areas, and any activity that requires a reduction in fossil fuel combustion will have natural co-benefits with reducing greenhouse gas emissions as well. Air pollution is also quite a topic that's recognised by some in the public, and so there is the potential to address potentially poor public perception. Assessments also help to identify the need for mitigation where uncertainties exist. So why is air quality important? It can have significant public health impacts in the UK. A report in 2013 found an equivalent of 28,000 to 36,000 premature deaths per year. Things will have improved since then, although for reference, during 2023 there were 1,624 road deaths in Great Britain. So you can see a comparison there. In 2020, a coroner's report found that the leading cause of Ella Advocacy Deborah's death was due to exposure to poor air quality during 2013. She lived near to the South Circular, which is a significant road carrying lots of traffic generating emissions that runs through parts of London. Between 2017 and 2025, it was estimated to have cost the NHS £1.6 billion, and there's also an increasing awareness of impacts on designated ecological sites, both due to the damage on plant species and the animal species that those plants support. You can see differentially how air pollution can affect people throughout their lifetime on the side as well. So in children, for example, you can have the slower development of lung function, development problems. In adults, it can affect health conditions. We've got coronary heart disease, stroke, and lung cancer, and so on and so on. There are various sources of air pollutants, and there are numerous pollutants of concern, including carbon monoxide, ozone, and sulfur dioxide. As I said, it comes from various industries, road transport being a significant one, industrial processes, agriculture, energy industries, as well as non-road transport. The ones that we're going to focus on today include nitrogen oxides, particulate matter, and ammonia. Nitrogen oxides, or NOx, include nitric oxide and nitrogen dioxide, and they are primarily produced during mainly produced during fossil fuel combustion. Short-term exposure to nitrogen dioxide can inflame airways, increase susceptibility to respiratory infections, and worsen symptoms in people with lung or heart conditions. Environmentally, NOx deposition can alter soil chemistry and harm biodiversity in sensitive habitats. Particulate matter consists of tiny particles in the air, some of which are toxic, and due to their small size, these particles can enter the bloodstream and affect the heart, brain, and other organs, posing serious health risks, particularly to vulnerable groups like children, the elderly, and those with existing health conditions. Ammonia is emitted from vehicles and other sources. It can form PM10 and also remain in the air for quite some time and travel quite long distances. Ammonia deposition can harm sensitive habitats by increasing nitrogen levels in the soil, and that will disrupt ecosystems by changing how different species grow. It can affect eutrophication, and it can also be directly toxic to plants, affecting mosses and lichens even at lower concentrations. There are lots of pieces of legislation which govern the amount of air pollutants that are emitted and the concentrations of air pollutants to which members of the public and workers can be exposed. In recent years, this has included the Environment Act 1995 as recently amended, and this introduced the Environmental Targets Fine Particulate Matter Regulations 2023 in England. Between them, these regulations established legally binding targets to reduce fine particulate matter concentrations to 10 micrograms per meter cubed across England by 2040, and to reduce population exposure by 35%, both compared to a 2018 baseline. For new developments that are coming forward, the National Planning Policy Framework requires that planning policies and decisions should sustain and contribute compliance with relevant limit values or national objectives. For PM2.5, the standards are slightly less strict than the legally binding target, but DEFRA have published interim planning guidance, which signals that the main focus should be on minimising exposure to PM2.5 and maximising emissions reduction. For developments that come forward in London, there are also requirements for developments to be air quality neutral, so they need to meet or exceed benchmarks which essentially try to prevent degradation of air quality, which can stem from cumulative impacts across individual developments together. And the air quality positive requirement for certain types of scheme that require an environmental impact assessment essentially sets a framework to achieve the same goal as DEFRA's interim planning guidance, i.e. to minimise exposure and maximise reduction. For industrial sources, you've got the environmental permitting regulations, which govern industrial installations and licensed waste management facilities, amongst others. For some processes which emit to air, emissions guideline levels, which are set, which can't be exceeded at the source, but these activities generally are required to implement best available techniques, and this will require that you, which require the prevention and minimization of emissions of pollutants or harmful impacts, and that can include impacts on air pollution. On top of this, the conservation of habitats and species regulations provide that authorities can't authorise plans or projects that can adversely affect the integrity of a European level nature conservation site, either alone or in combination with other projects. With the EIA regulations or planning policy for smaller schemes, developers and so on will need to consider how sources of pollution attributable to their development could impact on sites, and that can be national or local sites as well. And ammonia can be an important consideration in those circumstances, particularly because with nitrogen it can contribute to things like eutrophication and impact ecosystems. So some of the steps that you can use to mitigate impacts are what we're going to discuss next. At construction sites, most emissions can be controlled through various instruments, including a dust and air quality management plan, and this will comprise good practice measures requiring things like water suppression and covering and sheeting potential sources of dust, such as stockpiles. This is because dust can contain the finer particles such as PM10 and PM2.5, which can also pose a health risk. Plans may also include measures which can be used to monitor concentrations of PM10, such as at the site boundary, to check that measures in those plans are effective. Non-road mobile machinery includes mobile machines and industrial equipment, such as stationary generators, which are not intended for transporting goods or passengers on roads. NRMM sold in the UK market must have a GB type approval in Britain or an equivalent in Northern Ireland, and these are based on standards that are set in retained EU regulations. These standards set emission standards with which engines must comply when they first enter the market. But as you can imagine, if they're used for long periods of time or if they're sold second-hand, then their emissions might be more polluting than sort of cleaner, more modern engines. You can see an example of a study of source apportionment of air pollution in Hackney from an air quality action plan of theirs, where you can see that actually that is quite a significant source of air pollutants that were assessed. This is PM10. In London, there is actually a low emission zones that requires all in-scope non-road mobile machinery to be, such as excavators and so on, those things at construction sites, to be registered on their website so that they can be inspected. The emission standards for non-road mobile machinery with variable speed engines, i.e. the things that can move like excavators, currently have to meet stage 4 standards, and from 2030 that will be strengthened to stage 5, and in 15 years time you'll only be able to use zero emission machinery. To achieve compliance, you can take actions such as reorganizing your fleet or upgrading their engines. Constant speed engines, such as those found in mobile generators, are required to meet emission stage 5. As will be mentioned later, trips made by road can also generate pollutants. The emissions from road vehicles can be curtailed by implementing steps to reduce their emissions. So you could use freight consolidation centres. You could set a requirement that vehicles used in construction meet clean air zone, low emission zone, or ultra low emission zone standards where they exist. You can restrict on-site parking, and that's used for commuting. You can use travel plans that will encourage a shift away from, it will provide measures that encourage a shift away from using your own cars or own vans and so on towards more sustainable methods of travel like buses and cycling and so on. Operators of fleet vehicles serving the site as construction activities progress could also be registered with the Fleet Operator Recognition Scheme. And you might also consider transporting goods by by river and rail travel. Although do be careful that you're not simply displacing pollution from one place to another. It would need to be something that actually doesn't affect different people instead, essentially. To mitigate air quality impacts from things once they're actually built and or operational, you can do some of the following. So you can alter the building structure, which might consider the shape, orientation, height and location of buildings relative to sources of pollution in the area. So for example, you could have, if you've got too many tall buildings surrounding a source of pollution, such as local roads, then you could trap the pollutants, or that would trap the pollutants and can create a street canyon, which can be quite significant. And vegetation in some circumstances can also do the same. Approved document F in the building regulations requires that ventilation systems should be designed to minimize the intake of external air pollutants where an air quality standard is breached or where it's located near a source of significant local pollution, such as an underground car park or traffic junction. It recommends mechanical ventilation systems can be used to achieve that aim, and the inlets should be located as high as possible and on the less polluted building facades. They should also be located away from sources of pollutants, such as don't have them in enclosed courtyards where there's a outlet from a source of pollution, such as a boiler or so on. There are also measures you can take to restrict airflow into the ventilation system, where it's unavoidable to locate them in those areas. Alternatively, you could also consider a filtration system which is fitted to the inlet of the mechanical ventilation system. The thing to bear in mind with that, though, is that there are costs and design constraints. You need to make sure that the filters are changed and maintained, so you'll need access. Where cooling strategies are designed to use natural ventilation, at least in part, air dispersion modelling can be undertaken by consultants such as Temple to identify locations of poor air quality where mechanical ventilation might be more appropriate instead. Whilst non-openable windows will, of course, prevent a certain amount of air from outside getting into the building, you do also have to consider other things such as safety requirements. Other measures you might take include realigning the road network, if you can, away from to move pollutants away from receptors if your road is the source of pollution. You might also consider planning the area density differently, so reducing the number of tall buildings, as I say, to create street canyons, and that will help in those circumstances with dispersion. The future homes and building standards are currently expected to require buildings to be zero carbon ready, which will mean that, for example, homes need to be capable of distributing heat from renewable sources, and so gas boilers, a source of NOx, will not be permitted. However, where boilers are still used, at present, ultra-low NOx boilers with emissions of less than 40 milligrams of NOx per meter cubed, commercially available boilers are desirable. There's also guidance which outlines how vegetation can be designed effectively to minimize pollution, exposure to pollution at receptors, which is essentially outlining different strategies you can take depending on the orientation of the road and those receptors and local buildings to the prevailing wind direction. So you can see an example of the screen that it will give you advice on when it's robustly beneficial to use certain vegetation strategies, so green infrastructure, and where actions that might be beneficial to some at the expense of others. That sort of activity might be most useful at master plan stages for large development schemes and along roads with high levels of pollution. Other things you can do, so where road traffic is, or traffic as a source of pollution, we've mentioned road realignment already. Other things include making sure you've got provision for electric vehicle and electric bike charging points. There are actually commercially available bike sheds with charging equipment in them that you can install, for example, in individual dwellings. You might be able to do the same in communal areas. EV charge points, there are minimum numbers and power outputs that are set in approved document S of the building regulations that must be met. I believe it's about 7 kilowatts of power, which is quite slow. So do make sure that you consider the intended use of a scheme and consider it having higher power output where power output needs to be more rapid, such as at shopping centres and so on. In terms of industrial emissions, most environmental permits that are issued for emergency or life-saving equipment where their gross thermal input is 1 megawatt or more, smaller generators which are only used in emergency circumstances or for testing and servicing that are less than 1 megawatt will be excluded from the environmental permitting regime. However, all generators will benefit from things that will facilitate dispersion, such as ensuring stacks discharge vertically and without a cowel, and limiting testing and servicing hours. Some local authorities recommend generators are powered with using hydrotreated vegetable oil, and whilst it's similar in its chemical and physical properties to diesel fuel, it does have a lower carbon content and can also help to reduce NOx and particulates. One study, for example, found that the use of hydrotreated vegetable oil led to around 6% lower NOx and 35% lower smoke compared with ultra-low sulfur diesel. Certain industrial installations, which are regulated by an environmental permit, such as data centres operating in emergency circumstances using diesel generators, will need to have those best available techniques we spoke about earlier. But where that isn't enough to stop air quality impacts, things like selective catalytic reduction or increasing stack heights or increasing discharges velocities will be required to be used as well. Finally, things such as zero emission generators that use batteries are actually available as well to be considered. I'm now going to hand over to Zane to go through our case study.
Thanks, Daniel. Yeah, so I'm just going to give a brief overview of one of the projects that Temple's been working on, I think, for the last couple of years now. This one's quite a large, nationally significant infrastructure project located in the southwest London, Surrey area. And it's essentially a flood alleviation scheme for which Temple did the air quality assessment, as well as the noise and the climate assessments. And that was in contribution to the environmental statement for the DCO application. So essentially, these kind of developments are designed to reduce the risk of flooding, and especially with climate change impacts expected in the future. So that's an increasing likelihood of severe rainfall events in the coming decades. I think these kind of projects will become more and more essential as time goes on. So this particular scheme also aimed to improve biodiversity through the creation of new habitats, as well as providing new green spaces that the public can enjoy as well. So quite a few different purposes for this scheme. And you can see in the image here, that's an example of a different flood defense scheme, just to show you the difference that these kind of developments can make to flooding. So in terms of the scope of the assessments for air quality, given the large excavation works and a lot of associated transportation of materials, there were quite a lot of different elements to assess in terms of the impacts for air quality. So this was both during construction and operational phases. So we had the construction dust assessment. This was a qualitative assessment using the IAQM guidance, and that was looking at emissions of particulate matter and dust from the various construction activities. We also looked at odor. So for the construction phase, this related to excavation works. So that was like soils being unearthed, which can lead to odor impacts. And for the operational phase, that was impacts related to changes in channel flow rates of the river. And that can have an effect on fish and ecosystems, which can also result in odor impacts. for receptors nearby. We also undertook our own in-house monitoring for this. So you can see, if you just go back one slide, Daniel. Yeah, that picture in the bottom right there, that's just an example of one of the diffusion tubes that we set up for this project. And so on the next slide, this shows the existing monitoring networks in the local area. So this is what's being operated by local authorities and was already available. And I suppose the main purpose of our monitoring was mainly to fill in the gaps of where available monitoring wasn't available. So in the next slide, we can see, yeah, these pink circles here represent where we set up our own monitors. And this was done using nitrogen dioxide diffusion tubes over a period of 6 months. And essentially the purpose of this was just to get some more accurate baseline information where monitoring was missing, and also help with the accuracy of our verification for the modeling exercise. So in terms of challenges that we faced for this assessment, the main things that we faced were, firstly, as is often the case for these kind of large infrastructure projects, there was a substantial construction period that spanned over a long period of time and over quite a wide area as well. So that meant potential for high emissions of pollutants associated with the excavation works, the movements of heavy-duty vehicles on the local road network, and machinery within the site boundary as well. Another issue with this project was the large number of sensitive ecological sites. So that included habitats and ecosystem that were in proximity to the site. So that was that included designations on the local level, on the national level, and on the international level as well. So the image on the left here, you can see, just to illustrate the sheer number of ecological receptors that were close to our site. And similarly, the area in question also had quite a few air quality management areas, or AQMAs, in proximity. So these are areas which are known to be areas that are known to have poor air quality. So they're more sensitive to changes in pollutant emissions. And yeah, the image on the right here just shows in the blue overlay, those are the areas that are designated as AQMAs. Just to summarize the preliminary findings of the detailed dispersion modeling that we've done for this. So for the human receptors, all the impacts are negligible. So that was quite a positive finding. No significant effects there. But for some of the ecological sites nearby, there were predicted to be some exceedances of the critical levels for nitrogen deposition. So following these results, the next step was collaboration with the project ecologist to discuss how we would deal with this. And that's kind of the stage that we're at now. So these discussions are ongoing, and our modeling work will inform the decision-making criteria for how to move forward with this. So I think just to round off now, just finishing off with why choose Temple, what we have to offer. So we have quite a lot of expertise in many different disciplines with our multiple in-house teams. And I think this really helps enable our flexibility and ability to offer bespoke services and give our clients the best outcomes for whatever their specific priorities are. And this is possible with our extensive EIA specialists, experts in multiple technical fields. And we also have our in-house climate and carbon team, which is interlinked with our ESG offering. And on that note, I just want to mention that we have our climate and carbon webinar next week, which will be on climate resilience and net zero. So for anyone interested, that'll be happening next week at the same time. That's all from me. Thank you.
Yeah, thank you, Daniel and Zen. We are now open to the floor. Happy to discuss any questions or queries you may have. If you prefer, you can type your questions or queries in the chat box, the Teams chat, or you can raise your hand. Very happy to take questions if you would like to speak as well. So over to you, everyone. Thank you for listening to us. So the information about climate and carbon webinar for next week, Thursday, same time, 1 to 2 o'clock next Thursday, has been popped in the chat box as well. And my colleague Harry is also helping with Q&A. Yeah, any questions? Hi, Dan.
Hi, Sean. Thanks for that. Thanks to the team for that one. Really interesting stuff. Obviously, a lot of that is on the neighborhood scale. For those people who, and that probably be the majority of us, that live in naturally ventilated houses that were built many decades ago and weren't sort of conscious of the air quality design criteria. What are some of the best retrofit cheap measures we can do for our homes to improve our indoor air quality that's coming from the outside? I've got an air quality sensor in my bedroom, and I'm shocked every time watching the graph every time I open the windows and the particulate matter 2.5 and how that shoots up. So I'm wondering what we can do on a local level individually.
Yeah, that's a really good, interesting and a practical question. I wonder whether Daniel would like to elaborate on that a little bit.
I suppose it's probably quite difficult to do things if you have windows. However, I think one thing to point out first is the exposure to PM 2.5 in terms of how it would be looked at from this in terms of complying with legislation. You'd actually take a concentration average over a year, and you tend to find that occurs in only quite small hotspots. So it might not always be quite such an issue, depending on where your home is. You know, if you don't live near a fairly significant source of pollution, you might find it's not quite so bad. I suppose there are things that you can do outside your home when you're sort of out and about. So there are some initiatives where you might actually try and find routes where exposure to air pollution is expected to be lower. You can also sign up to AirText and other services similar, where you can get an idea of how poor air pollution is that day. So you can get an idea of how your exposure can be minimized. And there is actually sort of a color chart, for example, that you can look at that will tell you if air pollution is quite good that day, or if it's so bad that it might be recommended you stay indoors. And I believe, yeah, they're sort of publicly available things you can look up.
Okay, brilliant. Thank you. Yeah, I'll look them up. Thanks.
I probably just add on a little bit in relation to that. For example, recently the wood burning kind of directive coming, which means if your wood burning stove is not meeting the criteria and standards, you shouldn't really be allowed to do wood burning at home. I know this is quite a lot of people thinking that may not be harmful because it's such a winter comfort. Particularly with energy cost is high. And however, wood burning does emit a lot of particulate matters, particularly harmful in an indoor environment as well. So that's probably just add on to that, if that's relevant to some kind of residential conditions like that. We have another question for Maya. The London plan requires air quality monitoring at construction sites. What technologies are out there that can be used for measurements, and how costly can those be?
So I can answer that if you like.
Sure.
So there is, I suppose you possibly could divide them into three different categories. So the first one would be doing visual inspections. It's often something that's undertaken by construction site managers, where they might have sort of just see if there's any obvious signs of dust outside the site or near the boundary, see whether it's being generated on site visually, and acknowledging that fine particulates, some of which can be toxic, can be found within dust. Then you might take measures to control that dust using water-based suppression, or, as I mentioned earlier, sheeting for stockpiles if they're not covered up already, and things like that. So that's quite a cost-effective solution for construction sites or anywhere with stockpiles or similar. For measures, there are also passive measures, such as dust discs or frisbee gauges, that can be installed, where you can essentially collect samples of the amount of dust that land on them over a specified time period, and you can work out the dust deposition rate. There are criteria that you can compare that to, and where it exceeds those criteria, you might say, well, actually, on-site measures to control dust haven't been significant enough, so you need to take a bit more action. They tend to be quite cheap. They're more in the sort of the hundreds of pounds per piece of kit. Or to go up again into sort of the third category, you might have a continuous monitor. There are some reasonably reliable certified ones that are commercially available that will be in the thousands of pounds, and they will actually measure the concentrations of particulate matter in real time. And where thresholds are breached, such as those in guidance from the Institute of Air Quality Management, then that will notify, for example, a site manager at a construction site or even an industrial site, which we've seen before in environmental permit plans. And essentially, where that happens and it's attributed to activities on site, then immediate measures can be taken. That might mean ceasing a certain activity, or it might just mean implying that mitigation that I spoke about a moment ago. There are other monitoring measures available for other pollutants as well, which can be important at sites that are being remediated. For example, gaseous volatile organic compounds as well. But in terms of dust, they're the three that are typically used.
Thank you, Daniel. Any more questions? Or queries? You can always also contact us at our team email, and or contact individually via LinkedIn, and or just contact one of our Temple colleagues as well if you have anything would like to discuss further. I guess there is no blank solution for it all. It's really, we'll have to putting that into context, particularly as air quality impact, where the locations are, where the topography, where the exactly surroundings, and so on. So you really need a bespoke solution to all the to the air quality impact or pollution matters. So it's a lot of things to be examined, to make sure the solutions are fit for the purpose, as well as to achieve that environmental sustainability goals, as well as consider the social impact at the same time. Any more questions? If there are not any more questions, we're happy to conclude today's webinar. Obviously, this area is very complex. There's a lot to be discussed, lots to look into, particularly sometimes situation can be a bit tricky depending on how that can be applied. So you're very welcome to contact us, contact our team. Once again, thank you very much for joining us. Hope we'll see you at our next webinar, which we will be looking at climate, carbon, as well as sustainability services and how that can help us to achieve meaningful environmental and social changes. Thank you very much.
Thank you.